Hello guys, welcome to Medverse, and today we are going to discuss one of the most important topics for your NEET PG as well as INI-CET. INI-CET, many advanced topics are asked from this specific topic, that is epidemiology. Okay, epidemiology. So epidemiology is basically a very important chapter as per your NEET PG and INI-CET point of view, as well as your board exams of your third year. Okay, so starting with epidemiology, we'll try to cover the whole chapter in complete detail. So in basic terms, the study of disease in all its aspects, right? The study of disease in all its respects or aspects, you can say, is epidemiology. Study of population is demography, and epidemiology means epi means up, demios means people. Okay, means it is above people. Above people means it is a broader concept. It's not like only the study of population or people, it is the study of. So coming to the definition given by John M. Last. Okay, so John M. Last gave the definition of epidemiology. It is the study of distribution and determinants, okay, distribution and determinants of health related states or events or diseases. Okay, we have three things. This is the study of distribution and determinants. Distribution and determinants. Okay, a distribution of a particular health related state and what are the factors causing that health related state of health related states or events, okay, or diseases in specified population groups. Okay, it's not like that it's applicable to all, it's not that broad, it is broader up to a specific extent. Okay, and application of this study to control health problems. Okay, we have to apply the study, this is a study, and this application also comes under epidemiology. So application of the study to control the problems. Okay, so it's the complete definition given in your Park textbook. Epidemiology is the study of distribution and determinants of health related states or events or diseases in specified population groups and application of the study to control health problems. Okay, John M. Last was the man behind the definition of epidemiology. What are the components studied in epidemiology? So we have three components basically. Frequency, what are the number of cases of a disease? Distribution, what is the description of the disease with respect to time, place, or person? Means a disease is spreading to how much, in what time range. Okay, is the disease very fast progressing, is the disease very chronic one, a slow progressing one? Which areas are affected? Let's say of Odisha, which areas are affected? Diseases in Chhattisgarh, let's say which areas of Chhattisgarh are affected? And person. Okay, means about the determinants or the factors of person, like if the person affected by the disease were immunocompromised, if the disease is following a inheritance pattern, if the disease is lifestyle related, right? Disease determinants, why and how it is occurring. Okay, why the disease is occurring, what factors are leading to that disease, and how it is occurring. Means is the what is the pathogenesis, what is the uh, you can say transmission cycle, is it a zoonotic disease? Okay, so how it is occurring is basically the etiopathogenesis of the disease. Okay, understood. What are the components studied in epidemiology? Now we are going slow, but as we move forward we'll increase the pace, right? Okay, talking about disease frequency, it is measured in terms of ratio, proportion, and rate. Okay, ratio, proportion, and rate. Will understand what are these three terminologies. And disease frequency is measured in incidence and prevalence. Incidence is the number of new cases. Prevalence is the existing cases, new as well as old. When you say a thing is prevailing, means it is going, वो चलता जाता है, right? Incidence is a new one, is a new terminology. Means we say that 20 COVID cases happened today, and after this cases, we are left with 3,820 existing COVID cases, right? Along with this 20. So this is a new case, this is the incidence, right? and 3820 are the new as well as old, because it is involving this 20 also, right? So new plus old, this is prevalence. So what is the presence of disease in a population over time? Okay. Distribution, describing a disease with respect to time, place and person. When first COVID came, it was described as pneumonia of unknown origin in winters at Wuhan area affecting male population. Okay. So distribution as with respect to time, that is winter, place, that is Wuhan, and person, that is male population. Okay. Disease determinants. So what are the determining factors of that particular disease is covered under analytical epidemiology. Analytical means analysis based, right? You can understand. So it talks about why and how of the disease, why the disease is occurring and how the disease is occurring, right? Okay. Now we come to very important terms: rate, proportion and ratio. Just pay attention to here what I am writing. Let me make a column like rate, proportion and ratio. Rate is all three, just follow me, all three are numerator upon denominator, numerator upon denominator, numerator upon denominator, right? Numerator upon denominator. A terminology, okay, where the rate, what is the rate? Rate in which, let's say, literacy rate is measured how much people are literate among people, right? So numerator is a part of denominator. Let's talk about ratio. I'm talking about sex ratio, so number of females by males. So numerator is not a part of denominator. Okay, so this is a basic difference of rate and ratio. Proportion, in this also numerator is a part of denominator, but here a time component comes. Okay, whenever there is a time component associated with numerator and denominator, we call it proportion, right? Understood? Okay, so in proportion a time component is there. That covers our tools of expression. Now we'll move to another part, that is the rate. What is the rate? Rate measures the occurrence of an event, disease or death in a defined population in a defined time period. Okay, so here's a mistake. So proportion, there is no time component. Sorry, I told you a mistake. There is no time component in rate. Okay, rate is there, right? Okay. Time component is there. Sorry. Here time component is present. Okay, that's a small mistake. Please correct it. Okay. So I'm telling that rate is measured by the occurrence of an event in a defined population in a defined time period. Okay. So numerator is a part of denominator and a time component is there. This is rate. Death rate of city A versus city B. Okay. For example, like this. So what are the types of rate? One is a crude rate, one is a specific rate, one is a standardized rate. Standardized rate is not much needed. Let's talk about crude rate. This is unstandardized. Okay. It does not consider age or sex composition of the population. Okay. We have, let's say a rate is measured based on a death rate. Let's say death rate is measured based on how many people over 60 died. This is a age. How many people who were females died. This is sex, based on sex composition. This is based on age composition. Okay, these are not crude at all, because these are taking in account the age and the gender composition of the population. Okay, a crude rate does not consider the age or sex composition of the population, like crude birth rate and crude death rate. Okay, specific rate, we have age specific, cause specific, gender specific, many can be there, because we are taking the age, the cause of the disease into account. So specific rate means a specific thing is there. Let's talk about proportion. I told you that proportion is only n by d with no time component. with no time component, right? So n is a part of d with no time component. Multiplier is 100. So n by d into 100 is the proportion. Let's take the example of ratio. What is ratio? So n by d, where n is not a part of d, is called as ratio. Understood? So let's take sex ratio. Number of females by males. Are females a part of males? No, not at all. Into 1000. Into 1000. This is sex ratio. This is the formula of sex ratio. Relative risk. Incidence exposed by incidence not exposed. Means exposed to a disease or not exposed to a disease. We will understand this relative risk when you talk about epidemiology in more detail. Just for example, I am giving this. Incidence exposed by non-exposed is basically relative risk. Okay. Are exposed a part of non-exposed? Not at all. Okay. Let's take the example of rate. Rate. What is rate? Rate is basically numerator by denominator, where n is a part of denominator and there is a time component. Is a time component, right? So incidence is a rate. Prevalence is a rate. Okay. But prevalence is classified. Just remember a very important point. Prevalence is actually a proportion. Actually a proportion, because there is a time component involved. Okay. Actually a proportion, but in park textbook, which is the standard one, it is given under rate. So I am classifying it under rate. Okay. But actually it is a proportion. Incidence is the total number of new cases in a population by total population at risk in 2000. Total number of new cases by total population in 2000 is the incidence. Prevalence, total number of cases. This is total number of cases. Cases comprise of new as well as old by total population into 100. This is actually a proportion. I told you multiplier is 100, right? Another example of proportion is case fatality rate. Case fatality rate, CFR, is total number of death due to a disease X by total cases of a disease X. Okay. What is the CFR of rabies? 100%. 100%, because it is a highly fatal disease, right? So case fatality rate is basically total number of death due to disease X by total cases of a disease X into 100. Okay. Let's talk more about incidence. Number of new cases of a disease or new spells or episodes of a sickness occurring in a defined population during a specified time period. This statement is very, very important. Why? A specified time period important, because it is a time component is present. That means it is under which part? Rate. It is a rate, right? Because it comprises of a time. So it is under rate. Understood? It measures rate at which new cases occur. It measures the rate at which new cases occur. Rate at which new cases occur. It is independent of duration of a disease. When you see, it is a number of new cases during a specified time period. But does it speak about the duration of disease? Duration of disease? No. It doesn't talk about duration of disease. Disease can be of less duration or more duration. We're talking about how many cases are there, how many new cases are there during a specific period. Okay. It is more important for disease of acute onset. Okay. And primary level of prevention talks about incidence reduction. Importantly, remember, we have how many levels of prevention? Primordial, primary, secondary, tertiary, quaternary to new. So primary level of prevention talks about reduction of incidence. Which study is used for calculating incidence? This is cohort study. Cohort study is used for calculating incidence. We'll talk about studies. We can have case control studies are there, case control are there, cohort are there. Cohort, many types are there. prospective cohort, retrospective cohort. Okay, many cohort studies are there. Okay, case series is there. We'll talk about all of them. This is a question, a very easy one. You can take a screenshot and just solve yourself. Special incidence rates. So attack rate, what is an attack rate? Attack rate is used during an outbreak or epidemic. How many diseases are, how many cases are there, and how many people it is involving by total population at risk. This is attack rate. Secondary attack rate is basically communicability or transmissibility of a disease. Okay, one person is affecting how many persons. Okay, this is the SAR or specific attack rate, SAR. Okay. So what are the uses of incidence rate? Controlling the disease, idea about the etiology, the pathogenesis, the distribution of disease, about the efficacy of preventive and therapeutic measures. Okay, it talks about how effective our measures are, how effectively we are able to control the disease so that new cases are decreased, right? And talks about effectiveness of health services provided. Talks about the effectiveness. What is the effectiveness? It is basically a screening tool. Okay, it's basically a screening tool for checking the effectiveness of the health services provided in the community. Okay, let's talk about prevalence. It's the total number of all individuals who suffer from a disease. So total cases, new plus old, but total population into 100. Prevalence is actually a population. Okay, so you can take the screenshot of this question also. Simple one. We have two types of prevalence. Okay, let's talk about two types of prevalence, then we'll move to other aspects. Okay, measurement of prevalence. We have two types of prevalence. One is the point prevalence, one is the period prevalence. Point prevalence, period prevalence. Total number of diseased persons in a defined population at one point of time. So how many people are diseased means new cases plus old cases, reminding you, because prevalence is there, not incidence. Incidence is only new. Yes. So total number of diseased persons in defined population at one point of time by total number of population at same point. So we are talking about a point. Basically, point prevalence means a snapshot. It is a snapshot of a population. You took a camera and took a snapshot about how many people are diseased at a particular point. So it is point prevalence. Like for April 30, 2022, community A has a population of 10,000. Okay, so and let's continue that. In a population of 10,000, the particular day, let's say 200 people are diseased, means 200 are new cases or old cases. 200 are both new plus old. Okay, so 200 people are diseased. So this you can calculate the prevalence. This is the point prevalence. This is a more common. Point prevalence is more common than period prevalence. What is period prevalence? Period prevalence is basically number of person with an episode of illness over a defined period of time. By number of person in the population over the same period. In a defined period. So here in point prevalence, I am talking about today's 26th June. I am talking about 26th June. In period prevalence, I will talk about 1 June to 26th June. I hope you can understand, and I hope I am making sense, right? So January 1 to January 30, 2023. Cases up to January 30th need to be measured, right? Okay. Incidence and prevalence. What is the difference? Incidence is basically probability or chances of developing a disease. Prevalence reflects the probability of chances of already having a disease or developing a disease. This new cases, this new plus old cases. Easy to understand. It is independent of duration of disease, but prevalence basically are measurement of old cases also. So it depends on the duration of disease, right? Incidence is calculated from cohort study, and prevalence is basically calculated from cross-sectional study. And we have a formula that prevalence is equal to independence into duration, P equal to I into D. This is the formula for prevalence. Okay. Okay, we have some one-liners. They are asked in your PG entrances, so we'll discuss this also. If a new preventive modality is lost, if a, is launched, let's say we have let's say colorectal cancer, and I'm launching some tablet, or you can say, let's say, a vaccine we take, vaccine X, which can prevent colorectal cancer. Okay, so after giving this vaccine X, some people are prevented, so it is decreasing the new cases, right? Decreasing the new cases. But is it affecting the existing cases in the community? No, it is not affecting the existing cases. That is, there is no effect on the prevalence. No effect on the prevalence, only incidence is decreased. Understood first point? Yes. Okay. If a new treatment modality is launched, let's say we have the same example, colorectal cancer. I discovered that a drug, let's say some X1, this drug, when given via chemo, is treating it. Right? Is treating it. So it's a new treatment modality which is launched. So I will treat the existing cases, right? I will treat the existing cases of colorectal cancer, right? Or I will guess that this person will have a colorectal cancer and I will give this drug. It's not like that, right? I will treat those who are already suffering from colorectal cancer, right? So if a new treatment modality is launched, there is no effect on incidence. The incidence of colorectal cancer will no effect. It is same as previous. But the people who were old cases, were previously suffering from colorectal cancer, will reduce. Old cases will reduce. So prevalence will reduce. Are you able to understand? Yes. If there is improvement in treatment, prevalence decreases. Okay, this thing we talked. Okay. If a new drug is effective in reducing death from disease but not curing, okay, it is preventing deaths. But it is curing? No. So we developed some drug A, which is preventing death. It is preventing mortality, but it is not curing it. It is not curing the disease. Means the person is suffering from disease, right? The person will suffer from disease for more duration. Okay, if he is not dying, then the person is let's say this is a person. The person is suffering from, let's say, lung cancer. The person is now 30 years old. He will die when he will be 40 years old. Let's say 40 years old. Okay. Now you give that drug A, which I discovered. That drug A will prolong the life of person. It is preventing the person to die at 40, but it is not preventing the treatment. It's not curing the lung cancer of this person, but it is basically preventing the person to die at early stage. So the person, let's say, survives after this drug A for 60 years. Surviving for 60 years. Okay. So previously the prevalence was 10 years, if you check for past 10 years, then this person will be counted. But here after this treatment, the person will be counted for 30 years, right? For 30 years he'll be counted as an old case of lung cancer, right? So basically, if this drug is introduced in market, it will increase the prevalence. It will increase the prevalence. Are you able to understand now? Yes. So it will increase the prevalence. If a drug is effective in reducing death from disease but not curing, it will increase the prevalence. If a new drug cures a disease, okay, then disease duration decreases. The person suffering from lung cancer and he is cured. So what will happen to prevalence? Prevalence will decrease. And in due course, in prevalence will decrease, the disease will no more be, you can say, progressing. So incidence will decrease in due course of time. This is a late phenomenon, but basically prevalence decreases. So prevalence is basically used in assessing the burden of the disease, is a direct resource to manage the disease. Okay, it is basically helping in managing the disease. With this, we come to the end of the first topic which I wanted to discuss with you in epidemiology. Now we'll progress more in this chapter. I hope you are enjoying the chapter. Let's talk about the second part of this chapter. Welcome to epidemiological study designs. We are talking about the study designs of epidemiology. In epidemiology, we have various study designs. Okay. So first we'll talk about observational study. You will be an observer and observe it. Okay. So here we divide it into descriptive epidemiology or descriptive study and analytical study. Okay. So lung cancer, let's say smoking causes lung cancer. Smoking causes lung cancer. You are observing how many people who smoke are having lung cancer. This is descriptive study. There is no comparison group. You are not comparing at all, right? Okay. This is descriptive study. Describe the occurrence of the disease in a population. Let's say you are talking about who are smokers and non-smokers. You are taking 100 people. Let's say 30 you took smokers. You took let's say 50. 50 you took smokers. 50 non-smokers. You are checking if who are suffering from lung cancer, who are not suffering from lung cancer. You are comparing the two groups. So you are analyzing, or a comparison group is present in the analytic study. Relationship between health status and other variables, right? Let's talk about descriptive studies more. So what, who, where and when are the questions which are answered in descriptive studies. Descriptive study is used to formulate a hypothesis that smoking causes lung cancer. This is a hypothesis. Now you have to test it. If the hypothesis is accepted, well and good. If it is not accepted, your study is failed, right? You believe in an alternate hypothesis. This is another topic. I'm not going into much detail. Prevalence of hypertension among phase 3 MBBS student of FMMCH Baleswar. Okay. Prevalence of hypertension among third year students in FMMCH. Okay. This is a descriptive study. Okay, but comparing this with people who eat breakfast and who don't. Okay, so now you are comparing that you are checking hypertension, but you have divided the phase 3 students into two groups. You are divided into two groups which take breakfast, B positive, which is not taking breakfast, B negative. You're checking how many breakfast taking students are developing hypertension, how many non-breakfast taking students are developing hypertension. This is analytical study because we have comparison groups, right? There is no intervention done. Very important line. There is no intervention at all. If intervention is done, then this will be interventional study. Okay. What is the procedure for descriptive study? You have to define the population to be studied. Population base. You have to define the disease under the study. You have to define a disease and a valid definition. Okay, which is applicable. It's a simplified definition. You won't use medical terms. You have to define the disease in a simplified definition. You have to describe the disease by time, place, and person. Okay, let's see how many types of disease are there based on time trend fluctuations. We have something called short term disease. Short term, so these are called epidemics or outbreak. We use the term outbreak, okay, because we deal with general population. So outbreak, epidemic or outbreak. Common source, propagated, and slow are the three types of outbreaks or epidemic. We have a common source epidemic, we have a propagated epidemic, we have a slow epidemic. Common source may be divided into three types: single exposure, point source, and continuous exposure. Single exposure epidemic, single exposure common source epidemic. One exposure and it leads to an epidemic. Common source, one peak only. Look at this. People took mess food. Mess food had contamination with cockroach. Okay. People fell sick. It is an epidemic. The mess has a common kitchen. There is a common source. It is one incident or many incidents? It is one incident. So, single exposure. People are taking food for one time, single exposure. So, food poisoning, Bhopal gas tragedy in which methyl isocyanate was used, right? These are the examples of single exposure point source epidemic. Propagated epidemics, let's say measles, hepatitis A, person to person transmission is there. One person infects another person infects yet another. Okay, this is a propagated epidemic. Periodic fluctuations, seasonal epidemics and cyclical epidemics. Some infections have a seasonal trend, like snake bite, more common in which season? Rainy season. Sunstroke, which common in summer season. Dengue, common in summer season, right? Then cyclical trends like influenza epidemics. Every year you took influenza vaccine. Okay, every year or every alternate year. It's a cyclical trend. Automobile accident is a cyclical trend, right? Then we talk about long-term trend, that is secular trend. Long-term trends are secular trends. Secular trends means it's a progressive increase and decrease over a long period of time. Let me give you an example. In older days, in your parents, grandparents age, people were consuming homemade food. So basically, let's say the NCDs, that is non-communicable diseases, were less in incidence. Okay, were less in incidence. Like your cancers, your diabetes, these were very less common in those days. I'm talking about let's say 1800, 1900. So okay, but now there is a increased consumption of trans fat. There is an increased sedentary lifestyle. There is an decrease in activity. There is a decrease in, let's say, taking of homemade food. People are preferring Swiggy and Zomato more. Okay, so now in current there is an increase in NCDs. So this in 2000s to 2025. So this is a periodic fluctuation. This is a secular trend. So secular trend is basically something that is happening over time, over years, over a long period of time. Understood? Okay. Place distribution. So in epidemiology, I talked to you about distribution and determinants. So we are talking about distributions. Place distribution. Carcinoma stomach, more common in Japan. Why? Because they take barbecued food. The smoke particles get deposited in the stomach. The stomach walls proliferate. Okay, the stomach walls proliferate, and we have a type of stomach carcinoma. Okay, the stomach size is reduced, and this is not expansile now. This stomach is called as a plastic bottle stomach. I hope you must have heard in your pathology. Or linitis plastica, plastic bottle stomach. Okay, carcinoma stomach. Goiter is most common in hilly areas because in water, in hilly areas, there is a seepage, right? So the iodine content is reduced. Water fluorosis is common in contaminated water with fluorine. Kala Azar in Bihar, UP, Chhattisgarh. Okay. Local distribution of a disease is identified by spot map. Okay. Now let me say a historical aspect that a spot map of London was prepared. This is a spot map. Basically, you have a map over here. There is a lane. Let's say there is a lane. There is a road here. There is another road. There are houses over here like this. Represent the houses like this. Represent houses like this. Let's say this is another lane. This is going like this. Okay. There's a tree over here. There is another tree. There is a house. There is a house. This is a spot map. Okay. Okay. Water sources. This is a water source. Let's say this is a water source. And in this spot map, they usually give spots like this. How many cases? Okay, here these two houses are affected. Let's say here it is affected. So this spot map of London was prepared. The spot map of London was prepared to study the cholera outbreak. The cholera outbreak was studied. And this cholera outbreak, who did the study? The study was done by John Snow, cholera outbreak, and this map is a spot map. This map is a spot map. So basically, we are done with spot maps. Understand what is spot maps? This is an important MCQ, so important remember. A disease is measured by morbidity, mortality, and disability. Okay, then you compare the known indices and hypothesis formulation. So formulation of hypothesis is a part of descriptive epidemiology. Okay. So in descriptive epidemiology, we have to discuss 4 things: case report, case series, cross-sectional, and ecological. This can be descriptive as well as analytical. Okay, because there is a involvement of any intervention, or you can say analysis based over here. So cross-sectional and ecological are a separate category. Case report, case series, cross-sectional, ecological, these are the types. Case report is basically investigation of a single patient, a single case. Talking about a single case. Let's say one person is suffering from any other disease, which is disease X. The person will have a case. We are studying the person, so we are studying a case report. Let's say 3 person came from Japan, and in India they are detected to have a disease Y. So we are talking about 3 persons. So this is a case series. COVID was a case series. Understood? Cross-sectional and ecological, we'll discuss. Case control study. This is the first topic we'll discuss. Case control study. Okay. So it is an observational, analytical, epidemiologic investigation. Okay. So we are done with descriptive ones. These are the descriptive ones. Now I'm talking about an analytical one. So case control study and cohort study are examples of analytical studies. Okay. Okay. So before discussing the case control study, I told you that we will make a mind map here, that I am talking about study designs. So write with me, study designs. So theoretical parts were there, so I was just not writing the things, but let's write. You will have observational study and interventional study. In observational, I told you that we have two: descriptive and analytical. In descriptive, what 4 we have? Case report, case series, cross sectional, and longitudinal. This 4 we discussed, right? In analytical, we have cross sectional. I told you that this cross sectional and longitudinal can also be classified under analytical, right? Longitudinal, ecological, case control, which we'll discuss now, and cohort. Under interventional studies, we can have non-random or quasi-experimental, and we can have random. Only one study, that is RCT, randomized controlled trials. In quasi-random, we can have another 4: natural experiment, that is the John Snow natural experiment of cholera example. We can have pre-post clinical trial. We can have cessation experiment, or we can have evaluation studies. This is the classification given by the Indian Association of Epidemiology, Indian Epidemiological Association, IEA classification. In PARC textbook, some mistakes may be there, so I am correcting this, and this is the classification which is worldwide accepted for epidemiology. Okay, study designs: observational, interventional. Okay, descriptive, analytical, non-random, random. Done. Then descriptive, case report, case series, cross-sectional, longitudinal. Analytical, we have cross-sectional, longitudinal, the same ones. Ecological and case control study and cohort study. Non-random, natural experiment, pre-post, cessation, evaluation. And random, we have RCT, that is randomized controlled trial. Okay, so these things you have to remember as per your epidemiology is concerned, right? The classification of, you can say, epidemiology. Okay, so these things are there. Let's start with the case control study. So what is the basic design of a case control study? Then we'll see the text. Let me first make it, then we'll go to the text. Okay, so case control study, we have a population. We define a population. This population, we take people with disease, and we take people without disease. People with disease, we call them cases. People without disease, we call them controls. Okay, and from these cases, you are checking how many are exposed to disease and how many are not exposed to disease. From control, you are checking how many are exposed to disease and how many are not exposed to disease. Okay, so this is the direction. Understood? So let's take an example. You are taking a population. Let's say I am taking Odisha. Person with disease, let's say I am talking about COVID. So here are the people who have COVID and here are the people who don't have COVID. Out of people who have COVID, let's exposed means who are positive for COVID and who are negative for COVID. Okay, and here from the COVID negative population, we are checking how many people are positive and how many people are negative for COVID. Okay, so first we are taking the case and control, then we are asking about exposure. This is the direction. So let's say cases, controls. Then I am making a column like this, a box, 4 into 4 matrix, exposed, not exposed. Let's say A are the cases who are exposed, B are the cases who are not exposed, C are the controls who are exposed, and D are the controls who are not exposed. Okay. This is the 4 into 4 matrix. Understood the 4 into 4 matrix? Okay. We have a term called odds ratio here. Odds ratio. Odds ratio is being equal to odds of being exposed. Odds means chances. Odds of being exposed in cases by odds of being exposed in control. What is the probability that a person is exposed in cases? What is the total number of cases? A plus B. The total number of cases A plus B. And what is the probability that a person is exposed? A. So A by A plus B by odds of being exposed in control. What is the odd? C. C by C plus D. Okay. This is the thing. But here we have defined a parameter which is not odds. This is about chances. So this formula, just write this and cut this. So here I want to make a negative note for you. This is not odds ratio, this is relative risk. Okay, this is not the formula of odds ratio. Odds ratio is AD by BC. AD by BC. This is the odds ratio. Okay, just remember the formula and cut this formula. Remember to cut this formula because odds are equivalent to probability but not equivalent, but not similar or not same. Okay, understood? Okay. So here we are going from disease. Case or control means we are talking about the disease. So we are going from disease to exposure. Disease to exposure. We are first talking about the disease, then we are measuring the exposure. Okay. So this direction is called as retrospective. So what is retrospective? Disease to exposure progression is retrospective. So a case control study is progressing in the retrospective direction. Odds ratio is AD by BC. You have to understand this, and what is the study design, you have to understand this. Okay, done. Yes. Then we'll talk about the next one, that is the cohort study. Cohort study. If I talk about the cohort study, we are talking about a population again. From this population, okay, from this population, let's say people who are wearing a mask and people who are not wearing a mask. Let's say I take people who are wearing a mask. Are they COVID positive or are they COVID negative? And people who are not taking mask, how many of people are COVID positive and how many are COVID negative? So this mask is the exposed or non-exposed. Exposed means mask positive and non-exposed means mask negative. And this is disease. COVID is a disease, right? Disease positive, disease negative. So here the study design is population, exposed, non-exposed, disease positive, disease negative, disease positive, disease negative. This is the study design of a cohort study. Case control, what is the study design? Population, case, that is disease positive, control, that is disease negative, exposed, non-exposed, exposed, non-exposed. Opposite direction. This is the study design of a case control. I hope you can compare and contrast. In cohort study, just remember that we are making a 4 into 4 matrix again. This time we are taking exposed, non-exposed here. Previously we took cases control here, that is disease positive, disease negative here. We are taking exposed, non-exposed here, and disease positive, disease negative here, right? A, B, C, D. A is exposure and disease. B is exposure but no disease. C is non-exposure plus disease, and D is no exposure, no disease. Okay, understood? Okay. Here we define a term called relative risk, which formula I made you cut there. Relative risk, RR. Odds ratio was OR, right? Relative risk. Here relative risk means, so here RR means the incidence of disease in exposed by incidence of disease in non-exposed. That means A by A plus B by C by C plus D. This is the formula for relative risk. Understood? Done? Okay. Now I want to tell you that whenever we have to interpret it, what is the interpretation? Odds ratio, relative risk, any of this depending upon the study. Whenever it can be more than 1, it can be less than 1, it can be equal to 1. I am talking about association. Okay, we left one thing. Okay, here. That case I told you about cohort. So in cohort we are progressing from exposure to disease, which is a normal direction. Exposure to disease. This direction is called as prospective. This direction is called as prospective. Okay, so case control is retrospective, cohort is prospective. Normally, I am telling normally. Okay, I'm telling normally. So odds ratio more than 1, less than 1, equal to 1. Whenever I am telling that odds ratio is more than 1, I call it positive association. Whenever I am telling odds ratio is less than 1, I am talking negative association. Whenever it is equal to 1, no association, nil. So association is the, you can say, how a exposure is related to the disease. I am telling that cobalt causes, let's say, lung cancer. So cobalt causes lung cancer, you have to study, and after the study, whatever you get, you have to check odds ratio and relative risk. Let's say cobalt is having a positive association, that is, it is causing lung cancer in majority of patients. That is, odds ratio relative risk is more than 1. So it is a association, that is, cobalt is causing lung cancer. So cobalt will be termed as a risk factor of lung cancer. Hypothetical example, don't take it seriously. For example, which is a proven one, smoking and lung cancer. You know smoking causes lung cancer. This has a positive association. Let's say cobalt is not causing lung cancer, but it is protective to your airways. Let's say you find out that cobalt is protective to your airways. So there is a negative association or inverse association. So cobalt becomes a protective factor. Okay, which is a proven protective factor? Vitamin C and colon cancer. So vitamin C is protective for colon cancer. This is a positive association. Let's say cobalt is neither causing lung cancer. There is no relation at all. Okay, there is no relation between cobalt and lung cancer. So this is a null value. Example, let's say eating egg and having let's say some disease, ophthalmological condition, let's say keratitis. Is there any relation between eating eggs and having keratitis? No relation at all. No relation at all. So this is a null value. Okay, this is the interpretation. Understood? Now we'll go to the difference which are asked in your theory exams between case control and cohort study. So follow me. Differences between case control and cohort. So what are the differences? Make two columns, case control and cohort. What are the differences? You already know. We know that case control progresses from effect to disease, exposure to disease. Okay, sorry, disease to exposure, and cohort talks about exposure to disease. Okay, here in case control we are comparing cases with controls. In cohort we are comparing exposed with non-exposed. I am sure you must be aware. We made this cases control. We are comparing these two, and exposure non-exposure, then ABCD. Here we made exposed non-exposed and case control, that is disease positive disease negative, and we wrote ABCD. Okay, I am sure you can relate, right? Okay, here temporality is absent. Here temporality is present. What is temporality? So this is a sequence. Temporality means exposure causes disease. This is the sequence. Here it is not followed because it is reverse. Here exposure causes disease. Yes, temporality is preserved, right? Okay, so this sequence, exposure disease to exposure, is there in case control. This sequence I told you, it's called as retrospective, and here it is called as prospective. Okay, case control study usually takes minimum resources, and cohort study usually takes max time, money, manpower. Okay, maximum resources. Here you will to calculate odds ratio, and here you calculate relative risk. What is the formula? AD by BC. Here what is the formula? A by A plus B by C plus D. Okay, here you are taking disease exposed or non-exposed, and disease like this, you are taking like this, right? So you are taking disease positive and disease negative, so there is no ethical issues at all. Okay, you are taking already diseased or non-diseased people, so here ethical issues are not there. But here you are exposing a person or not exposing a person, checking the disease. Here there will be ethical issues because you are exposing a non-exposing, right? This exposed person will have a higher risk of death, right? So here ethical issues are present. Important line now, that in this case control, multiple exposure can be studied. Because you are taking disease and non-disease, and you can study variety of exposure, right? Exposure 1, exposure 2, exposure 3, you can study anything. Non-exposure 1, non-exposure 2, non-exposure 3, you can study anything. Multiple exposure you can study. Here, multiple outcome you can study. Multiple outcome you can study. Means you are taking exposed and non-exposed. You are checking that some are diseased, some are carrier, some are behaving differently, some are having spots only, some are having rashes only. You can study multiple outcomes. It's not necessary that a person is like having only one outcome, that is disease. Person can present anything, right? So multiple outcomes can be studied. Here multiple exposures can be studied. Okay. It can be done for rare outcomes also. And it is only done for common outcomes. Okay, this is a point for INICT. Understood? Rare outcome and common outcome. Done? Okay. A question was asked in AIMS 2012 that a rare exposure common outcome, which study you will prefer? Tell me. Cohort. Yes, for example, a bomb blast. Bomb blast is a rare outcome, rare exposure, but common outcomes are there. Nuclear tragedy, nuclear accidents. Okay, like this. So this you have to understand. Okay, done? Okay. Now we are done with case control and cohort study. Let us see from the text which are given. So if I come to the text, I'm talking about case control study. We have already discussed. Let us quickly go through the text. Example of analytical as well as descriptive study to determine whether or not a statistical association exists or not, and if yes, to determine the strength of association. But remember, the strength of association can only be determined by statistical tests. Okay, epidemiology can only tell you about association exist or not exist, but how much is the power, the strength in which it is associated, it's only given by statistical test like chi-square test, ANOVA, okay, all this. So case control is a observation and analytical test. Unit of observation is an individual, okay, because it's not a population based study. Unit is individual. I talked about population, cases, control, exposed, non-exposed. Both exposure and outcome has occurred before the start of study. Okay, so you are just taking it. Okay, you are not doing any intervention. What are the steps? Selection of case and control. You do matching. Okay, measurement of exposure and analysis and interpretation. Selection of case and control. You give a definition of case, you give an eligibility criteria, it should be fixed. Okay, case can be located from hospital, clinic, or in screening source of cases, right? Controls must be free from disease. Controls means disease negative, right? It is similar to cases except for absence of disease under study. Control can be maximum 4 control can be taken. Must be taken from population at risk. Okay, from the same population, cases and controls must be taken from the same population, that is the population at risk. Okay, matching can be group matching or individual matching. Then measurement of exposure by interview, questionnaire, medical records, okay, all this. Analysis, I talked about cases, control, exposed, non-exposed, right? Okay, we're comparing this A, B, C, D, A by A plus C, B by B plus D, all this. Okay, remember this table is reversed. This table is reversed. So this table is reversed, and whether it is associated or not is checked by test of significance. I told you that chi-square and t-test, and estimation of risk, odds ratio. I told you that AD by BC, A by C by B by D. Okay, and this is an example. You can take a screenshot and solve the example. And this I told you already. Advantage, it is easy, rapid, no attrition bias, which we will study in the bias in the next lecture. Risk factors can be identified, minimal ethical issues. I told you that cohort has more issues. And disadvantage is a bias which is there. Bias, what is bias? I told you, I will tell you. Cannot measure in incidence. Okay, this is incidence, not incidency. Cannot evaluate therapy, do not distinguish between cases. Okay, all of this. Examples of case control: thalidomide, adenocarcinoma, and cigarette smoking. TAC, thalidomide, adenocarcinoma, and cigarette smoking, and carcinoma lungs. These are classical examples of case control study. Cohort study, a type of analytical study to obtain additional evidence. Cohort is a Latin word, group of warriors, group of people with common characteristics. Study progresses from cause to effect. I told you that exposure to disease. Okay, exposure to disease. Cause means exposure, effect is disease. And when to conduct? Whenever there is a good evidence of exposure and disease. When exposure is rare, incidence is more. That is rare exposure, common outcomes. I told you rare exposure or rare incident, common outcomes. Okay, this is done. When ample funds are available, I told you that manpower and all are more required. For common diseases, case cohort is usually done. Rare diseases, I told you, case control, right? Okay, and this exposed and non-exposed we are taking in one column, disease plus disease negative in another column, A, B, C, and D. Okay, I told you. Types: historical cohort, prospective cohort, combination cohort. And these are very common cohorts, very classical cohort examples: Framingham's heart study, Doll Hill study, and oral contraceptive and health study. Doll and Hill have criteria, 10 criteria. I will talk in some other lecture. Framingham's heart study, Doll and Hill, and oral contraceptive and health study. Okay, DOF, degree of freedom, say like this. So Doll and Hill, oral contraceptive, and Framingham heart. Okay, retrospective cohort will talk in other video. Steps: selection of study subjects, obtaining data, selection of comparison groups, and follow-up and analysis, right? Ideal cohort should be stable, cooperative, committed, and well. Cohort means a group of people, right? So they must be stable, they must be cooperative with you, they must be committed to completion of the study, and they should be well informed of the procedures, because consent is a very important part. And we calculate relative risk in this. I told you incidence among exposed by non-exposed, that is IE by INE, right? RR1, no association, more than less than 1 positive, more than 1 negative. Okay, so this is more than 1 positive, this is less negative. Okay, just there's a reverse here, change it. We'll talk this population attributable and attributable risk in the next class. And advantages and disadvantages you can see from here. Okay, disadvantages: basically large number of people are needed, very long manpower, time, money, person, and all. Loss of medical records. And original cohort may be like, some people may go to some other places, may migrate, may immigration. All of this affect cohort studies, right? Because we are taking a huge number of person, may alter person's behavior, ethical issues are more here, right? And advantages: bias can be minimized here, right? Incidence can be calculated. I told you incidence can be calculated from cohort study, and prevalence from cross-sectional study, right? Estimate relative risk, dose response ratios. Okay, all of this. And this table I discussed with you in detail. So with this we come to an end with case control and cohort. In the next lecture, that is lecture number 2, we'll continue with all the things. And that's all in this lecture. Thank you, and have a good day and good night. Okay, bye.